So let's go ahead and look at the first example. We have the natural log of the sixth root of e. Keep in mind that the natural log is the same as log base e. So we're going to rewrite this as log base e of the sixth root of e. So we're going to change from radical form to rational exponent. So we're going to rewrite this as log base e of e raised to the 1/6 power. So now keep in mind that anytime our bases are the same, our answer is simply the exponent, which in this case is 1/6. And that should make sense because a logarithm is an exponent. So this is asking e raised to what power gives us e to the 1/6. So of course, e raised to the 1/6 power equals e to the 1/6 power. So our next example, we're simplifying the natural log of 1. So we're going to rewrite this as log base e of 1. So keep in mind again what this is asking us. This is saying e raised to what power equals 1. And we know that any base, with the exception of 0, raised to the 0 power equals 1. So in this case, the answer would be 0. Our next example, write the equation in its equivalent logarithmic form. So when we're writing it into logarithmic form, the first thing that we do is rewrite the word log. So the next, we're going to write down here in our subscript the base. So in this case, our base is 7. On the other side of the equal sign, since a logarithm is an exponent, will be our exponent, which in this case is 2. And here we'll have our answer, 49. So to check it, we know that 7 raised to the second power gives us 49. Next example, 5 squared equals 25. So we're going to write this in logarithmic form. So again, first thing I do is write log. My base in this case is 5. On the other side of the equal sign is my exponent. And the answer of raising 5 to the second power, 25. So again, to check it, 5 to the second power equals 25. Next example, we're going to write it in exponential form. So again, our subscript here is our base. So we have 4. Our exponent is the value 2 in this case. And we know that 4 to the second power equals 16. So our base is 4. Our exponent is 2. Our answer is 16. Next example, same thing. Here we have log base 5 of x equals 3. So our base is 5. Our exponent is 3. Our answer of raising 5 to the third power in this case is x. Our next example, evaluate the expression without using the calculator. There's a couple different ways to do it. So what we're going to do is change them so that they have the same base. So here we have 4 raised to, and that's what we're looking for, x will equal 2. So right now these aren't the same base, but I can rewrite 4 as 2 to the second power. So I still have that existing exponent x. So 2 raised to the 2x power will equal 2. And the exponent here, of course, is 1. So once I have the bases the same, what I'm going to do is set my exponents equal to one another and solve. So my answer would be 1/2. My next example, same thing. I'm going to start by changing it into exponential form. So my base is 10. I'm looking for my exponent, and that's going to equal 1 over the square root of 10. So I need to change these so that these have the same base. So this is 10 to the x power equals 1 over 10 to the 1/2. Keep in mind when we're writing this and it's a rational exponent, that's the same as a radical. So we're not quite there because the bases aren't the same. This is a fraction and this is base 10. So I need to express this as base 10. Since this is in the denominator, that would represent a negative exponent. So that's 10 to the x, just copying what I have here, equals 10 to the negative 1/2 power. Again, since my bases are the same, to solve, I set my exponents equal to one another. So in this case, x equals negative 1/2. My next example, again, we're talking about writing or simplifying without using a calculator. So anytime we have log, remember the base, if it's not shown, is base 10. So I want to know what 10 raised to what power is going to equal 0.01. Now 0.01, I'm going to change to a fraction to make it easier. So this is the same as 1 over 100. So I need to express these as having the same base. So here it's 10 to the x equals 1 over 10 squared. 10 squared because 10 squared is the same thing as 100. Again, I'm not quite there because this is a fraction and this is base 10. So I need to express the fraction as base 10. So again, keep in mind, since this is in the denominator, it represents a negative exponent. So this would be 10 to the negative second power. So since my bases are the same, I simply set my exponents equal to one another and solve. X equals negative 2. Now my last example is the same as the previous example, but it's already in fraction form. So again, since this is log, no base shown, it's understood to be base 10. So I'm saying 10 raised to some power equals 1 over 100. So I need to express them as having the same base. So 100 is the same thing as 10 squared. So I have 10 to the x, and again, since this is in the denominator, this represents a negative exponent. So this is 10 to the negative second power. Since our bases are the same, we set each one of these equal to one another, the exponent equaling the exponent. In this case, there's nothing to solve, so my final answer is x equals negative 2.